How's it going, everyone? Welcome, Eulier Gonzalez here. And, well, let's continue to look at the chapter 2 to explore and to finally understand now some of the key aspect in your JavaScript understanding. So first thing first, we went through describe is what is JavaScript, why the name JavaScript, which is a artifact of marketing shenanigans, and who made that. What was the name? What was the code name known in the company that built that? For example, Netscape, and who owns now the legal notice or the who owns the trademark, right? Which is Oracle through a series of acquisitions. And to understand now, the TC39 is the commit that oversee is the technical aspect of the language by describing and oversee is which champions or proposals actually make all the way up through a series of steps from 0 to 4 in this particularly series of phases or this journey where a proposal needs to make the way all to the way you need to make all the way up to the top. It's something that can take weeks, months, or even years. So because of that, and since the spy that the TC39, the spy is this spec, and because they don't know the reality of the web, do this divergence between is even though that the commit is made of several folks that actually is working on these web related industry, browser makers, device makers, but not all of them knows the reality of the web, which is something that browsers implementation or JavaScript engines actually are known for, and they are more closer to the reality, right? In big in essence is because JavaScript implementations are prior or JavaScript engines are prior to the TC39 commit. And therefore, of course, they know a little bit more about the reality of the web. And there's some tragic and comedy events that happens. For example, is known as the Smushgate, where the TC39 have to go back to the drawing table and now refine the proposal again. But the TLDR is that most of the times those JavaScript implementations must stick to the law, right? So because of this diversion, which is something that is similar that happens to JavaScript developers when they don't understand how the JavaScript language works, and when there is this diversion, all right, that's when the box enters here, and this is something that Kyle Simpson actually described. I agree with what he mentioned, all right, and also with the ability to understand what the technical spec actually is describing, is talking about. So, in terms of that, seems this diversion of understanding is also true for every any of these environments that we work in. So each one of those environments, whether it's the browser, the server, the light bulb, robots, right? But most likely is client and the server, browser and the server. Each one of them expose certain features that we can work with, all right? So this, besides that, there is a several collections of environments that we can run JavaScript. The only reality that matters is the web. And even though, especially when you look at console logs, which is part of the dev tool from browsers, this doesn't mean that this is a true JavaScript engine. This is a JavaScript friendly environment. A good example of that is how, for example, the language, particularly the console log now treat is they use a string, for example, or hoisting, or for example, when you define is a global variable, whether it's a variable or a function definition, and they now append that to the window object. That name append that to the window object, which is not true on a JavaScript file or in a JavaScript application. So the idea of this, and understand that the different approach that we can work with JavaScript, which is procedural, functional, and object programming, and all of this is approach to solve problems, and the only way to solve a problem for real, for sure, is by understanding the problem. Now, because of this, and the majority of solutions out there are actually is now trying to provide some fix on top of fix on top of fix on top of fix, and there is nothing wrong with that, but you will never get into what the real problem you're trying to solve. In any case, so because JavaScript is at the end of the day is a compiled language, if not in essence, but in practice is a compiled language. Why is this? When you look at now how compiled language works, which is traditionally is take and analyze all of your files, all right, and then create now something called the abstract syntax tree. But first thing first, it analyzes all of these files for any errors, all right. And if everything went well, it create now this abstract syntax tree, which is a map to indicate internally the computer, or to represent internally the computer, how we going to process, for example, statements and expressions. Statements are calls to actions, or expressions are evaluation of values, right? Declarations, function definitions, function expressions, async functions, generator expressions, and declarations, if statement, iteration statement, so on and so forth. So it creates now this internal representation in a tree-like structure. And once that is done, usually it now creates a binary representation of the program that is be ready for delivery in that distribution. Why am I mentioning this? Because a true interpreted language, if you have now 5 lines of code and then suddenly at the line 5 you have an error, syntax error, reference error, you name it, what happened here is that this particular line of code, it needs to wait, or the engine, the interpreter needs to evaluate each one of line until it reaches to that particular line of code, which is not what happened in JavaScript, or at least in ESModules. How do you know that? Well, when the language is evaluating for errors, and this is not something that is I can actually show you a particular message, right? But the spec actually describe certain semantic syntax. And this semantic syntax is describing, for example, is early errors. So a good example of that is, let's take a look now at the function classes, which I do find that this is what will happen. So for example, when you look at this, static semantics is doing some early errors. So the language in itself is saying, hey, for example, if the code is a strict mode, you cannot have any identifier as a string value of eval or arguments. So in other words, So if we evaluate this particular instruction here, we say, hey, that's going to say eval, right? I want you to eval this function, and then say, hey, this is the console log of eval, right? So eval, eval function, right? And then I execute this, right? And then now it's run. And you may wonder why this is working well. If you, for example, do this, you are now overriding the eval function that actually exists. So, for example, if you use now, in this case, not at all this. In this case, if you do, for example, they use a strict, all right, it say, hey, you cannot is name now is eval or arguments. Again, all of this is just doing a series of early errors that this is what happens before your code even get executed. So what happened is that when your JavaScript file leave your ID, the process is that it's usually transpiled to a browser safe code via a transpiler using Babel or TypeScript. All right, if you're using TypeScript, and then now this code, which is different from what you wrote, is gonna be parsed. It's gonna be bundled up into something that is ready for delivery, usually through a Webpack or Vid or any of these model bundlers. So why this is important? Because as we evaluating or as we or as the code now is shipped and is delivered, once that code now is evaluated by the JavaScript engine, okay, is going to now is converting to a natural syntax tree is going to run this static analysis or this static semantic for early errors, all right? And if everything went well, it's going to create internally an abstract syntax tree that, depending on the JavaScript implementation, is going to be transformed into some intermediate representation of the code for further refinements and further optimization that is going to be passed through the compiler that live inside of the JavaScript engine. And once that is done, all right, now your code is executed. And because this is a concern for a lot of folks in the ecosystem, right? When you say things like, hey, if we want the parsing and the execution phase is something that is it raises concern because we can consider that slow, right? And there is a concern of that because it can be slow. So there has been now attempt to show that JavaScript using now the ASGM.js, which is a subset of JavaScript that now allows to port is an Unreal game engine into the browser at 60 full FPS by providing some hints to the JavaScript engines to run some further optimizations. It actually set the precedent to now for WebAssembly, which is not an attempt to replace the language, is in fact is via the spiritual successor AS.js to say, hey, instead of passing now is hints to the JavaScript engine, let's go to now create this middle representation in an assembly like that allow us to target or that allows to target compile code. So in other words, we can now or by skipping is the parsing phase, and now allowing us to, given of course the compiler, is to act as this universal compiler target language, where you can now port is ROS, um, yeah, port code in ROS, Java, C, C++, and all, yada yada yada. The thing here is that via WASP, this universal target compiler, we can now produce is WASP code that can be executed in WASP environments. This go beyond the scope of today's video and this explanation, but the TLDR of that is that this is what the WebAssembly is. And it's not a replacement for JavaScript. In fact, it's just to be a this universal compiler target. So there's also another things that is important to mention, which is the strict mode, and how this is just to provide, to allow developers to provide some hint, or allow developers to give a is allow developers, yeah, which is something that I mentioned, but is allow developers to provide a some hint, or so the strict mode is allowing developers to so the strict mode in JavaScript allows developers to to allow this allows developers to provide this allows developers to give better hints, or to give hints to the JavaScript engines for further optimizations and execution of the code. So for example is this eval function that I mentioned, or the argument, as well as other things that we need to go with, right? So all of this is quite interesting and quite important to understand at least the basic. And when we move to the chapter 2, which is to describe now the serving of JavaScript, all right, and how that is, how our knowledge is actually solidified, or that actually based on stuff that it is. First thing first is to understand that each file is a program. So each one of those standalone JavaScript files are seen by JavaScript as a single program. And why is this? Because the way how this analyze the errors. So for example, if you have several of these tags, and one of them is for Google Analytics, or yeah, for example, for Google Analytics, or yeah, Google Analytics, or let's say jQuery for interactivity, or for any error tracking services, right? So on each one of them, if for example one of those files fails, your application will operate partially. Now this might be good or not, depending on your applications, but the only way that JavaScript see all of these files, or multiple standalone files that act as a single program, if they are at runtime access to the global state via variables defined in the global scope, or you export some data and methods via of these files. Because we also have now the ES6, which is this co-organization via using import, or using the script tag type model, all right? What's happening here is that each one of those files now becomes interoperable at runtime aka making them act like a single program. But the TLDR of all of this is that each one of these files, think of this, each one of these files as one small mini program that at runtime they can be now interoperable among themselves. So this particular notion is in order to understand how these different files will behave, how they work, all right? And as we progress and as we move to the language in itself to understand now what is a value, which is the most important unit of information in the language that allows to represent is the that allows to represent and manage the state of our program. And this state that our program can be is primitive or objects. In other words, the thing that you can represent are strings or numbers. String follow is the Unicode format, where the number follow is the IEEE 7054 spec. All right. And there are some nuance on that. For example, that is it is inaccuracy, so it has a particularly limit that we can represent when we run in some operations. And the other is that we have booleans, we have also begins, we have the kind of emptiness null and undefined, as well as the symbol, which is using for private data that you don't want to expose. And last but not least is the objects, and how now objects allow us to represent not only collections of values, all right, in this numerically indexed list, where we can held its values in each one of them, all right. But it also allows to yes. But it also allows to represent is different roles that array have, for example, tuples or lists, as well as objects, right? In objects, now this key map value when you have now the index and the collection, or the index and the values. And also, since now functions is a special type of objects, functions now is a value. So here in the JavaScript we have not only the primitive but also the objects as well as functions. So functions is now a value, and this is important because it unlocks a lot of these functional patterns that we can use, especially when the problem is relevant to computations or calculations. This is now how you can actually this is how you can improve. This is how you can approach this kind of problems, all right? So we have that. We have the functional programming. We have that functions are values. We also look that these functions that can be used as a value in an object. It unlock now a new hall of possibilities. And when you want to detect the value of value detections in JavaScript, you have now this particular keyword to detect all of the primitive except for null, which returns you an object. This go beyond the scope of today's video, but also is for functions, all right, that actually return you is a value, as well as objects, but not for arrays, right? So why I mention this is because to understand that functions is so fundamental in the language that is now a type of value. It is a value in it itself. So this is why I mentioned that you have the primitive, you have also the object, and also you have is the functions, because despite that array is something that is widely used in the language, is not returning us, it doesn't return us as a value. All right, there are other way of how you can detect that, but I think this is quite irrelevant when it comes to understand the values in JavaScript. And then we look at how we can declare variables and using variables. So because we can have literal values or values held in variables, and this variable has several syntax form that each one of them express in or behave differently. So vars are global or function scope, which in other words, these variables is describing is how widespread this value uh, can uh, can be accessed across our program. Okay, so whether it's a var, which is global or per functions, or whether it's a let, which is a more constraint, which is for per block, and it cannot be redeclared, but it can be reassigned. In cons, they cannot be redeclared or reassigned later on, must be once, and it is per block. And because the way of how we now assign or pass values in JavaScript is quite different than how do we do in other programming language such as C on Java, where you as a developer can explicitly indicate how you're going to pass this value, whether it's a copy of them, whether it's a primitive, or whether it's a reference as a pointer, right? So in JavaScript, we can have that access. The only way to do that is per values. This is the only way of how we can, as a developers, indicate that we're gonna pass or assign a value by copying it or by a reference. So primitive, the value are passed by copying it, whereas now with objects, their value are passed by reference. So I mentioned this because as we define is how can we declare is variables in the language, and also inside of our functions, right? We can is define is the variables as a parameters that are gonna be act as a variable inside of this lexical scope, or inside of this functions uh, execution context when that function is evaluated, right? Another place is a try and catch that is creating now these unique values, and the idea of describing is that those values are passed by value and by referring is especially useful as we describing is now how can we define our functions, whether it's a function declaration or a function expressions, and how the functions declarations, the association between the binding, the association between the identifier and their value happens is before the code is executed, right? At parse time, the expression functions, the association between the identifier and the functions happens is at runtime. So when that value is now evaluated, that's when the value. So when you declare the function, the name function or arrow function, and then you assign that to a variable, since functions are an object and objects are passed by reference, okay? So you are passing that reference to these objects, and therefore at evaluation at runtime is when that association happens. So, which is something that we're gonna see that later on in other chapters, more in depth, okay? And there are also some questions about how that things actually works, which is to me is quite like some sort of magic and stuff like that. And then we look at how can we assign its values to an object that at the end of the day, remember functions are values. We also talk about is the comparison, for example, the equality and the coercion or the conversion, all right? And how now, for example, is on the comparisons, since their values are now comparison by equality, all right? And this is something that might be, so in other words, is use the identity to compare if the value it is itself, all right? That's why we call this triple equals to check their equal, to check the equality, or to check it is identity, all right? So for example, for primitive values, that actually work as expected using the triple equal. However, for non-objects or for positive and negative values, that case actually behave now quite different. And I'm not gonna lie, the point of this is if you want to make sure that the value you're comparing actually it is what it is, all right, it is identity, it is the same as it is, you go with object doris, which is like the triple equality, exactly, the triple equality here. Remember that when you define our objects, because the comparison is being made by its identity, all right, is this represent is the same. So for example, 42 represent is 42, all right, or the true represent is the true, or the false represent is the false, all right, because that actually is not only is that the equality here, the triple equation, is also is performing is some coercion, which is something that you're gonna get used to that. But the coercion here is a way to convert one type to another type, whether it's from a string to number to string, for string to big int, or the undefined or null to a string or to a number, and the symbol as well. You can do that. It is quite not used, but you can do it. For example, string. You can use this string to symbol. Here is a secret. Right? It gave you now is this as it is. So is this one you cannot use here because it's not detected. Symbol is not a constructor function, but this is how you can assign your symbols here, right? Let's say you say, hey, this is secret, right? You assign this and you say secret, right? And this is what it is. You know, coerce that to a particular string. But again, this coercion that happened here, especially with this equality, is something to keep in mind, as well as the equality that I mentioned before, and it is coercions, right? Let me take a break here. I'll be right back. And we're back. All right. So now when we talk about is the coercion, all right, which is first thing first was the equalities and the coercion, all right, or the comparison on the equalities and the coercion, okay, and how in the coercion we have is this abstract operation, which is just a fancy way to say that this is an algorithm that is going to be performed when you do certain things. For example, when the language, when you, for example, or the language wants to is transform from one value to another. So this coercion, which is an abstract operation, and is defined in the spec, and you can take a look at that. So for example, at to primitive, to boolean, to primitive, to boolean, to string, to number, uh, and how each one of them follows a specific way of how it's going to coerce that into something. All right. So for example, an object into a primitive. All right. I am not well aware of that. Into an object, into a primitive. So this is known as a to operator to primitive. There you got it, right? This this abstract operation here, abstract operation, which is say, hey, I'm gonna receive is the input, and then I'm gonna receive um, some preferred type or some argument, some options here, and it say, hey, let's go to assert if the input is a particular value in JavaScript. If type input and then type is going to be a function here, algorithm within this spec manipulate value here is associated. If the type input is an object, then what it's gonna do is to say if the preferred type is not present, then the hint will be the default, all right? And then it's gonna jump to this and say let the exotic to prim, okay, get method of input from the to primitive, which is a private method here. If exotic prim is not undefined like this, then let the result be the call of that. All right, so let's go to call that object with this exotic to bring input and the hint. If the type result is not an object, return the result. Otherwise, return a type error. So whether this is an object, which is a callable object, or if this is not an object, all right, and return the result, and that's what it is. So you're gonna call the call. You're gonna call with this exotic to print input and the hint. So if the hint is default, set hint to number. So in other words, this algorithm is gonna prefer to do numeric operation, numeric coercion, rather than string coercion. So if, for example, we translate this into some specific code, like JavaScript, please translate this spec into JavaScript code, right? I put please, but there is no need to put please. Exactly. So to primitive is gonna say is gonna assert this. Assert input in ESModules value. in JavaScript, all values are ECMAScript values. And it's gonna say, hey, if this is an object and the input is different from null, all right? So what it's gonna do is to say, hey, let me check if the hint, let me determine the hint. So if I don't provide a hint, it'll be the default, or it can be string or a number, right? But handle the default as it is. And then you call here the get method. This is to actually is to call that object, okay? Or to verify that. And this is on helper method that is going to do this. But the thing here is that it's going to detect if the object has a call method. If the object has a call method, let be the result call the object here. So if the object is not defined and the result is now a call, which is calling this function, is function.apply, all right? Call abstract operations, call a function with a given this arguments. Hey, I'm gonna call this object because at the end of the day, this is, yeah, I'm gonna call this. And if this is not an object, all right? So if this is an object, well, it's gonna give it to me is this as an object, all right? So you're gonna return is the result if it's not an object. And then it's going to return is that. The point of doing this is to understand that the language in itself is going to prefer, let me actually, so it is safe to say that the coercion to primitive will prefer numeric coercion first. So it'll be prefers to exactly. So the default behavior, so yes, by default it prefers numeric coercion. However, the preference can vary, whether it's a string and context, all right? So when no specific type preference is indicated, to primitive default to numeric coercion. But in any case, if the hint is provide, then whatever string it is going to now do that. It's gonna be used to run that, right? So if the preferred string is this, let the hint be string or number, all right? And then I'm gonna call that input to primitive, all right? And as when to primitive is called with no hint, then it's generally behaved as if the hint were a number. However, object may override this behavior by defining two primitive methods. So, but in any case, I don't want to dive too much into this. This is also the ordinary to primitive, as I mentioned here. If this is the type, if type of is an object, and also assert that this is a string or a number. If this is a string, prefer to run now the to string and then the value of methods. All right. If it's number, prefers to run is a value of methods and then to string. All right. And the same for this is a list of order. So all of this. So the idea of this is just to look and understand what is the algorithm that is applied for this kind of abstract operations. And you might wonder why this is relevant for us to know, because this is something that is going to happen a lot of the time in JavaScript. Therefore, we should know to work with it. So this is this is now the serving in JavaScript. So first thing first, we talk about the files in JavaScript, all right? So how now JavaScript process files and how each program is how each file is its own program, and talk about the values, and then the what it represent, what is a value, why do we have this kind of values, whether it's a string or a number, a boolean, a big int, the kind of emptiness, undefined and null, as well as symbol, and why do we have now objects, what it represents, whether it's a collection of values or a key value pair, or a functions, and then how can we define is now is variables, and how can we use that, because so far we have looked at how can we express those values as literals, but we also can now hold those values inside of a variables, and we have different forms to define them, whether it's the syntax form, which is var, let, and const, and which one of and each one of them how now has its own constraint, as well as in a functions, given the named and the parameters. This is also how you can define is now variables or identifier here. In when it comes to describe is functions, and how can we look at functions, all right, which is not the way function here is a broad term, because we can use it like in a procedure by defining a series of statements and then run each one of them, and then now call this set of statements once or multiple times, that we might pass in a input arguments, or it can is return one or multiple different outputs. So unlike the strict mathematical sense of functions, which is a set of rules that must set abide, all right, the TLDR is that here with functions that replace the two roles in JavaScript, for the procedural, for the functional, we can now is define is whether is declare them first, the functions declarations, where their association happen is before the code is executed, all right, and the other is the functions expression, when the association between the value and its identifier happen is at runtime, when that line is evaluated. So we also look at how can we now is in those functions return now one or multiple collections of values, all right. If it is one single apple, we return is just a primitive. It's a collection of value. We can is as a collections or as a key map as well, as an object. And how can now our functions here, this is crucial here, how now our functions can be used as a value inside of an object to return something, all right. So this is one, and then we explore about the equalities and or the comparison in general, when we talk about the equalities and the coercion, all right, and how that, for example, is on equalities, because the unlike any other programming language, Java, C, you can now explicitly tell how you're going to assign or pass this value, whether it's by copying it, or by creating a reference. Here in JavaScript, we don't have that flexibility. The only way to indicate that is per values, whether it's primitive, when you are passing the object as a copy by value or by reference as an object here. And this is now plays a role especially on equality when you want to compare now, for example, the same type of values. So for example, for same type of values, actually for primitive, it worked as expected, as our intuition, but for objects, they don't. And it's because it is all based on this concept of identity. So is this value, it is own, right? So for example, is 42 is 42, there is no 42-ish, you know? There is no 43-ish. Is this value is the same as this value? Yes, it is. But unlike objects, since the way how now objects are passed and assigned, so anytime that you compare two different objects, which is you're reserving a space in memory that live in different places, all right? This is the reason why this actually, when you create these new ones, they behave like counterintuitive. They are not the same. They are not the same in terms of it is content. Where the language look at them as the identity, that if their values are their own, right? And this is why we have this particular concept, like if they are the same, it's like it's like trying to compare, for example, you and your brother. If you have a brother, you and your sister, you have a sister. If to see if you are the same, or if for some reason you swap sexes, you are the same. You know, this is when the context of identity actually is based upon. So for example, in the case of primitive, they are the same, so they have the same identity, all right? Whereas the objects, since unlike primitive, you can create space in memory, you can reserve space in memory. And since this space in memory live in different places, so they are not the same, they are not pointing to the same place. So this is why we have this equality, all right? And the other is the coercion. And how coercion happens, especially when you want to compare two things that they are not the same. So, for example, is whether it's using is a double, whether if you're using is a double equality or the triple equality in comparing is different types, okay? So what it's gonna do is to depend on the algorithm. If this is double equal, it's gonna pass through a series of steps. This loosely equality, and the other is the strict equality, which is this where we use a triple equal. But they have specific values where they are not follow or the intuition. So for example, is NaN and the positive and negative zero, right? So in other words, when that happens, well, you must know that using object.is is the one who is like the quadruple equality, but it's guarantee you that now both values are the same in terms of its identity, right? And for example, now if we use, for example, the object.is for not a number and not a number, right? It's actually give you now true. And the same for negative zero, and the other is zero, right? It tells you that it's false, unlike you have now this, which is true of them, right? So the thing here is that this is the core of this concept, the identity compare the equality identity or comparison identity, or the reference identity, okay. But it all boils down into the identity, whether it's by its copy or by its reference. And when we talk about is the coercion comparison, which is what's going on behind the scenes, is like we have to be aware and careful when you want to do this kind of coercion of different types, which is what happens a lot of the time with a lot of programs out there, that you use a particular type and then somehow, well, you think that triple equality is going to miraculously help you here, but they're actually not, and then, well, you find in some problematic in some problematic land. But in any case, the thing is that once we look at that and then how we organize our code in JavaScript, which is what I want to focus my attention in today's video, is this two major patterns for organizing code is data and behavior, are usually broadly across JavaScript ecosystem, classes and models. These patterns are not mutually exclusive, and many programs can use both. Other programs will stick other programs will stick with just one pattern, or even neither. In some respects, these patterns are very different, but interesting in other ways. They're just different sides of the same coin. Being proficient in JavaScript requires understanding both patterns and where they are appropriate and not. So classes, the terms orientate, and classes are all very loaded, full of detail and nuance, and they're not universal in definition. We will use a common and somewhat traditional definition here, the one that's most likely familiar to those with background in object-oriented language like C++ and Java. A class in a program is a definition of a type of custom data structure that includes both the data and behaviors that operate on that data. And here is the core of this. So a class is a definition of a custom type data structure that contains both data and its behaviors, okay, that operates on that data. So for example, here you talk about is this example here. So this is a custom class or a custom definition of a type data structure that include both, in this case is the data and its functionality, okay, or its behaviors, and that operates, these behaviors operates on this data. So classes define how such a data structure works. So classes define how such a data structure works, but classes are not themselves concrete values. To get a concrete value that you can use in this program, you must instantiate that. But again, classes defines as how a data structure works, how this custom type of the data structure behave. So in the program, a class must be instantiated with the new keyword one or more times. So in this case, as we can see here, we're defining is this custom type data structure that it contains the data and it is behavior that operates on this data. All right. Similar for class page and notebook. All right, it defines the data and its behaviors that operate on that data. Okay, so in the page class, the data is a string of stored text in a this.text member property. The behavior is print, a method that dumps the text to the console. Exactly. The behavior is print, a method that dumps the dumps is text on the console. All right. Exactly. So for the notebook, but this is from print. Okay, that dumps the text to the console. And for the notebook class, the data is an array of page instance. And for the notebook class, the data is an array of pages. Okay, the behavior is added page, a method that instantiates a page and then add that page to the list, as well as print, which prints out all the page of the notebook, where in this case is going to identify this, print all of this page of the notebook, right? So behaviors of methods can only be called on instance, not the class themselves. And as you can see here, this will be somewhat similar to an object with functions key value. All right, it might be the same. So behind the scenes, you can think of this like a normal object that is a constructor function and an add page and an it print, and also is this page as it is, this data as it is. So this statement, math nodes, new notebook here, it creates an instance of the class notebook, all right, where the data initially is this, and page, new page text is where instance of the page class are created. And exactly, when the add page, a method that instantiates a new page and add the list to the print. The statement math node creates an instance of the notebook class, and page equal new page text is where instance of the page are created. Example this. So anytime that you create now is this one. So behaviors methods can only be called on instance, not classes themselves, such as math node dot add page and page dot print. Right? So math node here is dot add page, which is a behavior, and page print as it is. The class mechanism allow packaging data, text, and pages to be organized together with their behaviors, add page and print. The same program could have been built without any class definition, but it will likely have been much less organized, harder to read and reason about, and more susceptible to bugs and sub-pair maintenance. Exactly. So the same program could have been built without any class definition, but it will have likely to have much less organized, harder to read and reason about, and more susceptible to bugs and sub-pair maintenance. Class inheritance, another aspect inherited to traditional class-oriented design, though a bit less commonly used in JavaScript, is inheritance and polymorphism. So consider this. This is the publication, okay? this custom type of a data structure that contains it is data and it is behavior that act upon that data. All right, and in this case, the print is just a simple one that just dump all the uh, data to the console. Title, author, and pub date. So this publication class defines a set of common behavior that any publication might need. And now let's consider more specific type of publication like book and blog post. So class book extend the publication like this, and then you have the constructor with book details, right? Where it say, hey, I want to call is the basic class with the publication and book details here. That'll be the title, the author, and the pub date. And I'm going to pass that to the base class of the book details, as you can see here. And then I'm going to have is this custom data from this custom type, all right, data structure, where it is publisher, it is ESB, all right, and here this is now the behavior that I have from here, right? So you say, hey, I'm gonna call is super print, and I'm going to add this behavior as it is. Similar for the blog post, which is I'm going to call is the super base class, and then I'm going to have is a URL like it is, and then I'm going to do this. So this behavior, this overriding behavior here is known as polymorphism. And it is polymorphism because it's a particular function is going to return is different output. All right. So both book and blog post use the extend clause to extend the general definition of a publication to include additional behavior. The super call in each constructor delegate to the parent publication. Class constructor for its initialization work, and then they do more specific things according to their respective publication type, aka subclass or child class. Now consider using this child class. New book. Then you guys this. You provide all of this, all right? And then you want to print that is. So your print now is a new book. For again let, which is perhaps, oh, in this case this is not a book, this is a blog post, all right? I do think this is quite David Welsh. Okay. In 2014, bro. Holy moly, bro. Mm-hmm. Mm-hmm. This was in 2014. Mm-hmm. Interview with a Pornhub web developer. What the? In 2019. Hmm. That's interesting. That's interesting. But again, is this David Wells? In 2016, yes. What my office look like? In 2016. So okay, so it was him. It was him. And then you got it says for games let.print title. There you got it. Notice that both client class instance have print method, which was override or of inherit print method from the parent publication class. Each of those overridden child class print methods called super.print to invoke the inherit version of the print method. The fact that both the inherit and the overriding method can have the same name can coexist. It is called polymorphism. Inheriting is a powerful tool for organizing data behavior in a separate logical unit, classes, but allowing the child class to cooperate with the parent by accessing and using its behavior and data. And then you have now the models. The model pattern has essentially the same goal as the class pattern, which is group data and behavior together into logical unit. Also, like class, models can include or access the data and behaviors in other models for cooperation's sakes. So they again, unlike functional programming where where if you have a problem that is computation, now with models or object programming, if your problem is coordination or cooperation, this is how you do. This is how you organize your code. But models have some important difference from classes. Most notably, the syntax is entirely different. Classic models. EXIS added a model syntax form to native JavaScript syntax. EXIS added a model syntax form to native JavaScript syntax, which will work in a moment. But from the early days of JavaScript, model was an important and common pattern that was leveraged in countless JavaScript programs, even without a dedicated syntax. The key hallmark of a classic model are an outer function that runs at least one, which returns an instance of the model with one of the more functions exposed. They can operate on the model instance internal, the hidden data. Exact. So, for example, using is the immediately invoke function expressions, which returns you now is an instance of this that allow you to work with this private or hidden data. Because a model in this form is just a function, and calling it produce an instance of the model. Another description for this function is model factories. Consider the classical model from the early publication book and blog post cases. Here you're going to define now is this co-organization, all right, that is going to have is, unlike a class, you have now a function where each one of them now are variables that we can define, similar to this, okay, that expose is now the methods here. This is the public API, right? And similar for the books. So we're gonna receive now the book details, right? And similar for the function here, we're gonna pass that plus the public API that we want to expose. And the same for the blog post. What we do wants to do the publication and the publication and publication. The relationship here, as you can see, is quite hard to read that. Unlike this, which is more straightforward to understand that, to where it comes from, right? Comparing this form to the class form, there are more similarities than difference. The class form store methods and data on an object instant, which must be accessed with the this prefix. With models, the method and data are accessed as identifier variable in a scope, without any this dot prefix. With class, the API of an instance is implicit in the class definition. Also, all data and methods are public, right? Exactly. So the data and methods are public. For example, here in a class. So the data and methods are public. So if you do something like, let's gonna do with this, right? So if we go and say, hey, this is the way how we're gonna do this, and then we create now new publication, say guns, a new book, say new publication, where here you're gonna pass the title, new book, all right, followed by the author, earlier, and the publication date, just a year, all right. And if we want to access to that, we can have access not only to the public data as well as the methods here. You can access to the title, you can access to the author, as well as the print method, right? So is this. Now, with models, the only things in here we're just exposing is the public API, the methods here, not the data. Okay, with class, the API of an instance is implicit in the class definition. Also, all data and methods are public. With the model factory functions, you explicitly create and return an object with any publicly exposed methods, and any data or other unreferenced methods remain private inside of the factory function. There are other variations to this function factory form that are quite common across JavaScript. Even in 2020, you may run across this form in different JavaScript programs, AMD asynchronous model definition, or the universal and common JS, classic Node.js style here. The variations are minor but quite compatible. However, all of these forms rely on the same basic principle. Consider also the usage, aka instantiation, of these model factors. So for example, like this and this. So the only observable difference here is that they don't need the new keyword here. Exactly. Is that unlike functions, with class you do need a new keyword. And then, all right, And then the ES models. ES models introduced to the JavaScript function in ES6 are meant to serve much the same spirit and purpose as the existing classic model just described, especially taking into account important variation and use case from MDA, UMD, and CommonJS. The implementation approach does, however, differ significantly. First, there is no wrapping functions to define a model. Exactly. The wrapping context is a file. And ESMs are always file-based. One file, one model. This is one of the reasons why it is safe for us to think that each one of those files are a single program that is going to be interpreted, is going to be processed by the JavaScript engine. And here with the ES models is telling you that. So second, you don't interact with the models API explicitly, but rather use the export keyword to add a exactly. You don't interact with the models API explicitly, but rather use the export keyword to add a variable or method to its public API definition. If something is defined in a model but not exported, then it stays hidden, just as with classic models. Third, and maybe most, so the first is there is no wrapping functions to define a model. The wrapping context is the file. And ESMs are always file-based, one file, one model. Second, you don't interact with model API explicitly, but rather use the export keyword and add a variable or method to its public API definition. If something is defined in a model but not exported, then it stays hidden, it stays private, similar as the classic models. Third, and maybe most noticeable, different from previous discussed pattern, you don't instantiate an ES model, you just import it to use in a single instance. You don't instantiate an ES model, you just import it to use it as a single instance. ESMs are in effect singletons, in that there is only one instance ever created, at first importing your program, and all other imports just receive a reference to the same single instance. If your model needs to support multiple instantiation, you have to provide a classic model style factory. Okay, you will have to provide a classic model style factory functions on your ES definition for that purpose. In other words, you're going to create now a function for that. So in our running example, we do assume multiple instantiations. So the following snippet will mix both ESM and classic model. This is how you do this. Consider the file publication. This is for classic models. This is for ESM. Sorry. This is for ESM. All right. And this is for now functions. Okay. This is for multiple instantiations. Print details and create. And here, this is how you're going to import that. Right. To import and use this model from another ES model, like the blog post.js, we do here. Create as create pub. All right. Here you got is the print details. And then the export function here, which is say, hey, I'm going to take now the create from publication, okay, and I'm going to add a new data here, a new parameter here. Pub is equal to create pub, title, author, and pub to create a publication, and the public API and what is going to be exposed to this. And finally, to use this model, we use import. We import into another ES model like main.js. Exactly. If you want to import in another model, we do this. This is from blog post. You say, hey, create as new blog post. And then you do is this new blog post. You don't need to actually create the new keyword because it acts as a ES6 model. It's this way of organizing code for against let, and then you get this. And note, as new blog post clause in the import statement is optional. If omitted, a top level function just named created will be imported. In this case, I'm renaming it for the readability's sake. It is more generic factory names of creates become more semantically descriptive of its purpose as new blog posts. As shown, ES model can use classic models internally if they need to support multiple instantiation. Alternatively, we could have exposed a class from our model instance of create factory function with generally the same outcome. However, since you are already using ESM at that point, I recommend sticking with classic model instead of class. If your model only need a single instance, you can skip the extra layer of complexity. Export its public methods directly. And the rabbit hole deepens. As I promised, at the top of this chapter, we just glance over a wide surface area of the main part of the JavaScript language. Your head may be still spinning, but that's entirely natural after such a fire hose of information. Fire hose of information. Después de una llamarada de información, prefería usar. Even with just this brief surface of JavaScript we cover or hinted a ton of detail you should carefully consider and ensure you are comfortable with. I am serious when I suggest reread this chapter maybe several times. In the next chapter, we're going to dig much deeper into some important aspect of how JavaScript works at its core. But before you follow that rabbit hole, make sure you take an adequate time to fully digest what we have just covered here. In the chapter 3, we talk about now digging to the roots. For example, like the iteration, consuming iterators, iterables, iterables, closure, the this keyword, and the prototype, as well as the object linkage. And the this revisited, and asking why. And then on the chapter 4 is the bigger picture. Oh, it's a bigger picture of that. So scope and closures, the prototype, and the type and coercion. Especially with the scope and closure here. What's the scope? Illustrating lexical scope, the scope change around the global scope, the not so secret life of variables, limiting a scope exposure, using closures, and the model pattern. Oh, here we are, exactly. Compiling code, tokenization, parsing, and code generation. Required two-phase, and the early errors. Compiler speak. Marbles and buckets and bubbles. Exactly. This is now, for example, is Why he have made this? Mhm. A conversation among friends. Engine compiler and scope manager. And the nested scope, look and failure, undefined mess. Building on metaphors. And then the scope change. Global unshadowing trick. Copying is not accessing. Illegal shadowing. Chapter 4 around the global scope. Oh, they describing as the web workers. Globally aware. Okay. The not so secret life cycle of variable. When can I use a variable? Every time that scope is entered. The term most commonly used. Hosting. Declaration versus expression. Hosting, yet another metaphor. Redeclaration. Least exposure, limiting the scope. Hitting in plain function scope. Mm-hmm. Chapter 8, the model panel. So that'll be all for this video. Take care. Bye bye.